We got it tacked on. It can come forward. Even estimated correctly, it goes all the way to the bottom of the hoe. Yes, I said bottom of the hoe instead of hole. Yes, people, the way I speak sometimes. I say that because I like backhoes and excavators. I like the word hoe. Backhoe, excavator. Backhoe's a little baby one. Let's see. Okay, we made a tool. I don't think we'd really covered that before. Oh, we left it out here. Ooh, on us. Got little marks on it. That wasn't good to do. Sometimes we're trying to duplicate doing stuff in the field the way we would if we were just doing it crude. We end up crude, so it's proper for the theme. Okay. What I did when I made this, it was already a turning tool, and it's being long enough, but I wanted to leave the flat for the set screw to set on, and I wanted to round so that we could just have a drilled hole for it to go in. And what I did, if you notice this, I turned it off center. I made this an 1/8 inch off center so that it left the flat there when I put it in the four jaw in the lathe. So we need, you know what size? Probably a 3/16. Here's an Allen. What's your eyes say?
Oh gosh, small.
Is it a Torx or an Allen?
Oh, it's an Allen.
Okay, then we should have it over there in the kit. I didn't remember. I've got an appointment for new glasses, and we need them. I could go get my inspection glasses that would work for this, but then I fall down when I walk across the shop, and none of us wants to see me fall down across the shop or on the stairs or anything, because it's just ugly. These are not real good holders, but you know, you just want something sometimes, and for as cheap as they are, it doesn't hurt to have a few really cheap things around. If you notice, there's no real pocket. The only thing that really holds it is the screw. There's no, you know, on a better system would have some kind of a pocket, at least partially hold on the other side to take the force. Doesn't really matter where it was made, it's just not a real good setup. Okay. Well, don't really know how close I am to everything. You want to go a different direction so I can see? Okay, looks like we're pretty much clear. Closest place, it's scraping over there. So I'm going to take, I don't think it's, I'm not trying for a definite size yet. I'm just going to squeak it out and see if we can find some metal. And we are going to turn faster than what you normally would because that's the speed of this drill. Let's see, you tighten both of these?
Yeah.
Okay, and I thought I tightened one of these and maybe the other one. Yes, I did. That one I did. Okay. Now we're cutting metal with power from our $200 and what dollar drill? Yeah, I don't remember. but there's more involved in that. I mean, you could use an old Jeep drive shaft. Actually, first time I did one with drive shafts like this, I used an old Jeep drive shaft. I expected that to run a little straighter. Did you get that a little over a 3/4 inch? Or was it 3/4 inch?
That was 3/4 inch.
What did we measure it with? Oh, because it looks like it's about 5 or 10 thousandths loose, which you'll get with a caliper sometimes. As close as you can get it is much more better, because it's not running. It's working. We're not going to reject it. Oh, no, we're moving. The drill's moving. Yeah, it's moving on the plate. Okay. Leave the magnet on. What we're going to do, yeah, because it moved way down. We got misaligned. Okay, I'm going to turn that off. We're going to line it back up straighter, which doesn't necessarily make everything perfect, but it'll make it better. And then we use auxiliary C-clamps, which I thought we might have to. You have to do that a lot of times. Magnet is, it don't do everything though. I'd probably grab some different additional versions also. But I don't know what'll fit. I like this, but I don't know if it will go in there and clear. It's not going to clear the U-joints. These are not quite as stouty, but we can put 4 of them on. That would be a design error if we didn't. There's no handle sticking on the other side. Maybe we'll just do 2 clamps. Yeah, they got spatter in the darn thing. No more welding in the shop. Been around shops that did stuff like that. This is ruining this part of the process. We can't do that no more. But it's a lot of what you do as a business. Nope, can't do it anymore. Nope, nope. I'm going to get another one for the other side over there. Did you have the drill safety locked out when you put your hand in there?
Nope.
Uh-oh. Don't tell anybody then.
I don't even have my tags.
Okay, I'm gonna back it up a little bit more because moving this might have brought it to where it went in a little further on the cut. Not real thrilled with that shaft. Oh, it's loose now too.
Oh, I don't know anything.
What?
What?
You're gonna have this tighteny side out.
That's how it was in there. I wondered about it too. Don't worry. I just didn't check.
Yeah, okay. Okay, Howie's Machine Shop, where if it looks okay, we don't check. Let's not make that our standard operating procedure. How could you? I mean, you gotta use the wrench. What, you use your fingers?
Yeah.
Oh my. They were finger tight. They were Burt finger tight. Man's got fingers. Fingers. Okay, so let us see. How bad is our bit? It's not too bad.
No, actually, it looks pretty alright.
So, come back a little more. Let's do it the easiest way out of what we got for figuring our cut. They make these little point sets with different things to them, and this one here is flat, which is nice for stuff like this. Now, you can put your magnetic base on the bar so that it's not moving. You can also put your magnetic base at a steady point and roll past the flat point. The advantage to putting it on the bar is that it's on the same piece that you're moving the tool against. The advantage to having it in a place and come across and find the high point is if you have to take this bit out and go sharpen it or replace it with a different bit. Now we're using an insert right now, but a lot of times you're using brazed on bits on these. And so if you're using a brazed on bit and you grind a little different radius, it's nice to be able to roll it to that high spot to reset from one bit to another and still have the same sizes. So you don't get that just by having the indicator in the same location, because you won't hit the same high spot of the bit because it's changed. The shape of the bit has changed. We don't need to worry about that right now. We're not going for extreme accuracy. We're just right now trying to make a hole that's cleaned up all the way around. And it's cutting fairly good. I actually feel like being greedy, but I'm not gonna. I feel like I'm like, wow, you know, with as good as this is actually taking, I should go 50 thousandths and try ripping some metal out. But I am a realist, and I think 25 is a more realistic, still somewhat greedy for our small setup amount of material. We could semi-compromise and go with 20, but I don't want to. So, whoops. Get your hand and eye coordinate. Oh, no, I don't want 20. I want exactly 25. No, 25 and a half is close enough. Okay. We can take another thing too, if we're really getting fancy with setting up our bar, and it's easier on bigger bars or bars with a holder behind your tool. You have another set screw that goes in there so you can just nicely push it. That pushing it doesn't give you 100% measurement, but it does give you an easy way to push it instead of like there where I was just trying to hold it. Now we have another problem. I don't know if I ground that off or not. I may have ground this off. Normally you grind the points off on your set screw that you're using here. I don't know if I remembered to or not. If I didn't, what it'll do is the little cup points in the set screw will keep trying to come back to their old hole. Now 25 thousandths, it still should make a new bite, but it gives you a problem with trying to bite back and move to an old location will happen. So you take your set screw and you make it into sort of like a dog head set screw where it's just more flat on the end. Grind off the part that bites in to make it hold. So let's try taking a cut. I'm going to go for earplugs now. It was a little noisy. Hopefully it ain't vibrating so much. Let's see. We might be dull. Yeah, not that bad. Just taking larger cut, more of the surface area. Gearbox is warm, not hot. Okay, I think I'm going to put a little whey oil on these bearings here. And if I put whey oil on it, it'd probably turn a little bit more, the bearing itself too. Just dull some, but I'm not ready to rotate it or do anything. I'd like to get a full circle, and then we will measure our hole and pick what size we want to make it to. Just for good practice while we're here practicing and playing. Don't really have a purpose for this. If you ever lost, this is the stuff, whey oil.
Oh, I just got that.
Yeah, whey oil. You don't know where you are, get some whey oil. If you're not sure what to lube it with, use whey oil. Okay, I'm not going to take as much of a cut as I did last time, since we are getting more contact. But I'm not going to go way down either. It was cutting fairly good. I want to get some pulled out. Better with a standard Allen wrench rather than this fold up for this. It'll work.
Do you remember what the minimum RPM on that drill is?
Well, it's 810.
Oh, it's just
It's not a variable.
Okay.
The variable one is the one we bought after we started using this one, and we haven't even opened it out of the box yet. We haven't actually even done a reveal on it. It was just the fact that this one worked good enough, and I thought the variable speed, which I recommend to most people to buy the variable speed one. Just that this is the one they sent us for free. And it's just an 810 fix. more careful feed, you take a millihex onto this, and then you put a speed reducer, torque multiplier, whatever you want on there for a little more control. Longer handle, just a longer handle, it's got more feel in it. I think we need to rotate our insert. It's not totally wiped, but it's not quite as good as it was. That's one of the other bad things I've noticed about these is they have lousy screws. The heads on the little screws that hold the stuff, the inserts in, try to strip off. But that whole set, I think, was $23 many moons ago. They're probably 40 or 50 now. I'm not saying everybody should have one, just don't poo-poo it totally, because once in a while, yeah, we get quite a little bit that's not hitting on part of it yet. That's question 2. Do we go all the way through this with this 800 RPM, which is working, or do we stop and try and use our other drill that has the variable speed and see how the variable speed works? Which we have not brought it out. It's the same basic format. It just got variable speed and reversing. This one I think was, no, this one didn't have a reverse, did it? We just shut it off when we were doing the tapping with it.
Yeah.
And if there's anybody out there from the old stomping grounds of where I went to college years ago, somewhere around Clark College, I stopped by there at Thanksgiving time, and they had shut down their machinist machine shop program for right now, but they're planning on starting it back up next year. They need some people that want to be instructors that understand some machining, but also other machining. You know, someone that's been through the course a while. They could use someone with an all-around experience and looking to get started up and training people again. It's actually the same course there, which I didn't realize until after I'd moved to Alaska. My dad started course there, and because of World War II, he didn't continue on. But he had actually been there for a few months taking the same classes, but 35 years earlier than when I was there. Learning to make a smooth hand feed, the way you usually start out learning that is by cranking the compound on a lathe for hours on some job in a small shop. And I think I want to turn a bit again. Yeah, I don't know. It was still cut. I don't want to tear the screw off though. No, I want to change it. I want to rotate it around. It's getting into some hammer marks in there that are, oh, it's warm too. hammer marks on the bore, whatever the reason is. Don't absolutely need to, but I want to get a clean bore. And if we wear out our drill motor before that, then we'll know that we shouldn't be using a light-duty drill motor for this. We should be using the big old Milwaukee. That's the first time I've ever used a real light-duty one. I have used some 3/4-inch hand-operated ones, which is no fun. A friend of mine has done quite a bit of it that way. And he says he's so sworn off of line boring because of such manual work that it takes, and then he takes on another job because somebody really wants it done. And it's a trouble a lot of times. Us machinists just kind of try to make customers happy, whether it makes the most sense or not sometimes. Two kind of a broad definition of two different, there's the machinists that, for whatever reason, sometimes because they've done it for lots of years, they're burnt out. And if they don't have the perfect machine that's going to do it right away, they say, no, can't do it, can't be done. And then there's the other types of machinists that he doesn't even have a shop, but he's got a hammer and a file, and he says, you betcha, $1,000, piece of cake. And then 2 years later, with his hammer and his file, he gets the job done.
Almost at a round hole.
It had a pretty rough spot right here. Take your camera over there, you'll see it. I can just feel it.
Oh yeah. Yeah, okay.
I wanted to get that yet.
Yeah.
Just cause. I mean, I don't have to. We could measure the rest of the hole, say that we did our wonderful thing, but we're here to make a clean hole. And by the way, that last cut was only 10 thousandths, so it seemed to like it a little better. Ow, ow, ow. I knew it was warm. It's still warm. Almost hot. Nope, too much. I see you filming the little sparks.
There's a couple of them.
Yeah. My nephew, years ago, I was showing him some pictures of a trommel build that we were doing. And he said, that is so neat. Can I have a copy of the picture? And then he cropped it so it just showed the sparks coming off of the cutting torch. Which, you know, that was the part that he was excited about. He used it for, I think he used it for some of the graphics on a car he was designing, you know, just the visual portion of a car. He was a few years younger than he is now. long time ago. So that's the problem with the higher RPM is we burn up the bits inserts more quickly than we should. If we had slower RPM, we wouldn't eat up the insert quite so much. On the other hand, for the money we're spending, it's not that, you know, if we were charging for this job, it would well pay for a few inserts. Now, something that just in general makes the line boring we're doing here, even with a drill, a lot better than what you get in real world line boring. Not that this couldn't be real world, but usually in real world line boring, you're lying in a hole. There's mud coming down. There's rocks. There's machine dozer going weep, 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 weep. You know, ruining your mind, all kinds of things. You're not in a nice shop with a crane and people around being relatively quiet and lights, and you're in a bad place most of the time. You're doing field line boring in the field. And so that adds to the not fun part of it. Which is what I really think they need to do. I've probably mentioned this before, but a welding test. You know, you have these out of position where you're welding uphill in your little booth. No, hang in by 1 foot, upside down, underneath something, just barely able to see it with a mirror. That's an out of position welding test. When you can do that, then you can weld. At least for that particular process. I still got to pass X-ray stuff. I might have one with a little bit larger radius. I had one radius and I had twos, and I even thought I had some threes. A two would be pretty good. These are ones. So they're breaking down the edge a little quicker, not just from wear. But it'll still work another cut. Still got a pretty good hole over there we haven't hit yet. I could, for the sake of people, but I just have to bear with it. Let's see how more of this goes, and then we'll measure it. Measuring it is a little bit of a trick. Like it's softer at the start of this than at the other end, but it could be just rough, nasty stuff. Not necessarily hard, or it might be hard. I torched 2/3 of a circle, two of them that were torched off that we cut with the saw and then tacked together. I think they were originally part of the mounts on a scraper or something. That's a bit. It's just a big enough piece of steel I couldn't keep fixing it out when we torched it off. It was on the machinery for some other reason and in our way. Did I mention where Clark College was for the people that don't know? It's in Vancouver, Washington, part of America. Lower 48 states. Near Vancouver, Washington's near Portland, Oregon is the location to find it. That does need to be swapped out. Rotated first. Don't suppose that thing's supposed to be metric, do you? Maybe.
I don't know.
Huh?
I don't know.
Well, it's metrics that I'm using now that worked with it.
Oh,
So it might supposed to be metric.
I can't believe you're using metric.
I think it's supposed to be metric. Yep. My fault. Not the tools. My fault. Okay, so if you got these cheap sets, they're metric. Now we know. Of course, it doesn't mean they're all metric because they're all copied after the same general idea, but not in the same swap. Yep, I know. I was greedy. 11 and a half is not 10. Getting smaller. Got a spot right there too. I wonder if this thing had been welded in line board before. You know, actually, we've got full cleanup now, though. That's maybe not a little pit there. I'm going to ignore that pit. We're going to start measuring and seeing what size we want to make it. So we need micrometers, the caliper. Paper's good too. Caliper, calculator. Calculator. And telescoping gauges. Huh. Oh, I was using, yeah, this 1 to 2 is out here already. I think we left it out here. Or no, I left it out on the other table. That was where I was doing that, yes. So, to measure the hole, we could make a tool, and there are some you can buy, that would come in here and touch inside and both sides with a little ball. But you don't normally have that. What you normally are going to have is the shaft diameter and a telescoping gauge that you can use on each side from the hole. And I say each side, a lot of times a person will measure on one side and then double that and add half the bar and then double it again. The problem with that is even though we got it as straight as we think, the bar may be setting a little bit one side or the other. And when you're trying to get your best measurement, it's best to have it, and I really should have measured that actual part of the bar right there instead of just measuring a part of it over here. Normally they run pretty consistent, but not dead on, and that is coming out a 0.5 thousandths under. So our bar size is 1.7495. That is our actual bar size. Looks like the telescoping gauge we want. Austin is being awfully noisy. It's probably what I pay him for. So when we go in here, I'm going to be letting this end of the telescoping gauge swing in the bore as it comes to closer and closer to the in line with the center of where we are on the diameter. But on the bar end, what I'm going to be doing is, as it's coming up tight, I'm going to back off just a little bit and hold this where it's setting. Rock this so that this stays in the bore, doesn't progress forward, and I'm going to try to find where it is the tightest and move it forward. And keep going back and forth and find just to where I can't find a tighter spot. And I'm not going to guarantee that anybody's going to get in here to see what we were doing. And getting your gauge first set, and so you got some kind of a setting is part of the harder part, actually, more so than swinging it through for size even. You can see a little bit there where that's the crude start, but where I'm making a bit of an arc and finding that point where it was the tightest, so I can back up there and pull a little bit more. Oops, I moved my far end, so then I can start back again a little bit. Another thing that we do here, okay, is we measure this, and we try to get 3 measurements that are the same. So 0.736. Of course, right now, I probably don't have a dead straight bore yet. The bit's a little broke down. There probably was some taper. It doesn't feel bad, though. It doesn't feel bad. And I'm kind of measuring in one place. There are other tricks. There's the people that sell that have a different version of the bar that comes with those. And it's got a hole through it that a telescoping gauge goes in, and you push your telescoping gauge in and back. But there's no guarantee, because it's just trying to hold this relatively correct in the middle of the hole. You don't get the chance to sweep it to find center, and you don't get the chance left and right to know that you're dead on center. It's just this drilled hole that's in there. I don't trust it myself. They tell me that you can get within 5 thousandths of an inch with that, which is not a real brag. Yeah, I'm sure you can. Now I'm doing my action from this other side this time. It's kind of got my finger in the way there. It's not the best on my techniquing. Yeah, it's better going the other way. But let's see what we get anyway. And if this bearing had been closer, that would have been harder yet. And that time I'm just a little over 37. That one I feel pretty good about. It's measuring 2/10 under, but I'm still going to call it 736 for right now. One of the things I learned right there was my finger has got to be inside near the bar. So with this offset more to one side, I got more room to move my fingers better with it turned this way rather than when I tried it that one time that was awkward, I had it this way. Okay. I'm getting 35 and a half. And we might even actually have that much variation right there because that was the first real cleanup cut. We could have had broken down bit. Just might not have been the absolute best. Let's just calculate from that approximately what our size is so we know what we're going to start shooting for. Then we'll take a little bit of a cut. We'll measure it even more carefully. Then we'll go for final cut. So what we have got is 1.7495 divided by 2 equals that much plus, I'm going to just call this 1.736. And then times 2 means that our current bore size should be 5.221. So we're going to shoot for 5 1/4. Now, do we shoot for this since we're pretending? Might as well shoot for the idea. If we were shooting for this for a pin, the pin was going to go through here and just stationary in this, and the nominal size is going to be 5 1/4. We're going to want to make it 5 1/4 to maybe 5 255, 5 thousandths over, 10, sometimes 15 thousandths over, because the pin wants to have a little room. The one that has to be more critical, and it's more of a problem, is, say we're going to press a hard bushing in this. Well, the hard bushing that we're going to press in at 5 inches is going to be about 4 thousandths over. It's going to be 3 or 4 thousandths over. So its size is going to be 5.250. Could be as much as 5, but probably 254 is a pretty common size. You're going to find it. And, well, you might get by, and it's not as good as it should be. You might get by at 252. It's better if you are right at the 250, or even a 249 if you've got a good press to push it in with. So we're going to shoot for a little under 250 on this so that we can be able to hone it. And I don't think I want to waste the stones honing it. We'll show about honing some other time. We're going to come back with the other machine. But that's what I would do if I was doing this. I would shoot for as much as, depending on how critical all the setup and stuff, as much as 5 thousandths under the size I actually want, so we can come back and hone it and know that we're getting the size we want for a good fit for a hard bushing in there. Fitting hard bushings is tougher, harder, than just a pin fit. Hole for a pin is not really a big tough thing to do. That's pretty easy. But getting it to where you've got a nice smooth. Also, the surface on here. I'm hand feeding this. It came out pretty smooth. This last cut came out pretty smooth. I was pleased with that. But some of the others had quite a bit of ridging, and if you don't have a good surface, even if your smallest part, your bushing fits in, it's not going to stay tight as if you've got full area. Because if you have the bore is like this, little bumps, and you have a hard bushing presses into there, it's really just setting on those high spots. But if you have a smoother, there's always going to be some, but if you have a smoother one, then as that sets in there, it's going to hit more of the surface. So, and the honing gives you that, but you can't always hone. And what some places, And you'll find this a lot, especially when you are out in the field and you're working for somebody else. Situation like this, you won't be able to hone. What you will be able to do is to sneak in an air die grinder and some flapper wheels. And 80 grit flapper wheels are pretty good for smoothing a lot of this out. And a lot of guys get pretty good at that. I get pretty good at that for some of the edges of stuff on hydraulic cylinders
Too. When we expected was in home. You'll find an industry slapper wheel produced for a whole lot more on the 1 and 2 off than what you normally think. So we're basically looking at taking around another 30, which would be 15 per side.
So if I turn a tool, and then I go for 7-ish, we already decided that that one is metric. I really want to go for 7-ish. I don't. I really like the idea of 3 5s better. So I'm going to come 5 just with this bit like it is. Then I'm going to turn it and do a 5 because I don't like to turn and get a brand new bit right on my last cut. I'd rather have it with a little bit of normal wear. And we're getting a lot of wear on this though. So there's trade-off. Yeah, I want to take roughly 5 thousandths on this. And I think that when we go to the next one too, we are going to we're going to get a regular Allen wrench. Yeah, I guess I don't need to. Gone this far without it. You saw how I moved, the number moved as the indicator was moving there. Now, with the 5 thousandths cut, another thing is going to happen. I am going to be easier to push, but it's going to be harder to push it at a consistent rate because the fight back from the tool cutting around there was giving me where I could pressure feed. There's 2 ways you can feed. One is, and you get better at this the more years you've done this stuff, where you just concentrate on how far you're moving at a time. That magnet is really getting hot. I don't think it was meant for continuous duty. It's been on there long. You could, if you were doing this, you could probably turn that off, let it cool down. The clamps are going to hold it, but I don't want to. Don't leave one of these on unattended overnight. I don't care Milwaukee who it is. It's just a bad idea. They will keep getting hot, and sometimes they can be. I haven't seen one catch fire. I also haven't tested the cheapy ones as far as catching fire overnight, but I've just always been leery about that, even in the Milwaukees. Yeah. So the other thing is, when you feed, it's a matter of feeling the pressure. It's the other way. You feel a certain pressure, and that's actually easier to do. And that's what I was doing with this last feed. It had a nice feel for the pressure, but I won't have that as much with the 5 thousandths cut. Lots chatter. Feels good though. It's a consistent chatter. Actually, it was pretty consistent chatter. I didn't expect that. I'm going to put back in earplugs. I'm going to take another measurement of that to see where we're at. And I think I'm going to go ahead and rough out one more and then take 2 even smaller cuts at the end than what I was thinking at first. Which could be a mistake with that amount of chatter, good, bad. It's hard to know sometimes. A lot of guess. There is definitely art to some of this. 39. That said, we only came up 3 thousandths for our 5. Which would make sense on the end there. The tool bit looks pretty bad. So, I think we only rotated this one once. Just warmish. There it is. So we had 5, but it didn't really take 5. So I'm not going to, it probably took 5 at the first of the cut, and then when it got hard later on, it did not. So I am going to, playing all of my artistic things here, I am going to go for a cut of 4 extra. Tightened in closer to 3-ish. Yeah, I need to move in things. Okay, I'm gonna call that it. For some reason she's harder down there. Okay. That was in the middle. There seems to be, see, sort of a coloration line. I can't feel it. It didn't slow down there, though. It slowed down further on. I don't know. I'm going to try this first part again. And let's do it with the opposite hand. Let's figure what if the 745 was just a bad measurement on John's part. Still coming out 745 over there. So I'm kind of believing there's a little bit of a bell mouth to it. Okay, now let's measure. You don't want to just measure sort of on this side and sort of on the other. You do want to measure directly across from each other when you're measuring side to side. So while I picked a place that made it easy to measure, that means it makes it hard to measure when I go to the other side. This is down here where I can't quite see it so good. That was where we had the taper last time. And it came out 746 on that one. And we pretty well need to take another cut, I know it. And we're saying we got 10 thousandths left to go. So, that's not bad. 10 thousandths left to go. It's about what I really was wanting at this point. What I'd like to do is put another new insert on and then move out my cut by 2.5. Because 5 thousandths will give me 10. And I don't want to just go ahead and take it and especially with this insert holder that doesn't have a definite. We're stopping this with a screw. It can move around a little bit as far as things are made accurate in the inserts. The inserts are all ground, a little taper in there is ground, but it's not exactly where it locks in. I'd like to put it in here. And this is where the lower speed would be a real advantage, because we could slow it down, save the burning of that corner end insert. So the second cut, because I don't want to turn this and just take a big cut. And the fact that we just made that new, I'm not sure which condition it was. I think it was that one. They're all worn a little bit, so in reality, if I take 2.5, this is going to take more. It will take more of a cut than what I dial in because of the insert being new right now. Figuring what we really want to do is 5 overall, but saying 2.5. Rather be on the safer side, which we are in a way in our measurements, so I'm going to go more for about 2 right now. Figuring it's going to take a little more anyway. I hope I did dog that screw. If I didn't, then I would say I must have ground it off, because otherwise it would have moved back to 0 again. The set screw would have pulled it right in. Definitely harder at the far end. It cut, I could feel it not cutting quite as even. It cut a little bit more than what we dialed in. I knew it was going to cut some, but I think it cut quite a bit more. And if we were being extremely concerned, we would have quit sooner and checked it sooner, because it might have actually cut the whole 5/1000ths with our dialing 2, and I knew. I say that from just looking at the cut. The cut looked like more than the 3/1000ths we thought we might take off with our 2 that we dialed in. And there we are at 7, 5.5. Exactly what we wanted it to be. You do that a lot of times. That was only on the one side. Yeah, you do that a lot of times. The more critical it is, the less you take. I thought about, but I didn't want to waste the inserts. And again, that insert not repeating. But I did notice. Did you notice that too? Did you notice that, Bert? Did it seem like more than 3, or did you even think about it when you were watching the cut?
It looked like more, yeah. That was really visible for being just 3.
Yeah, right. And that's that machinist sense. And I didn't look at it at first because I was thinking more about this over here, and the camera was in between. I didn't really look at the cut until we'd gone in about 3/4 of an inch. Then when we went in 3/4 of an inch, I'm like, oh, that looks like more. Normally I do look at the cut right away so that I can see if for some reason it's more. In this case, once we'd gone that far and we're making a video, I said, well, we'll go on through with it, and let's see. Let's see how we are on some more of these measurements. You know, that first measurement, I have a suspicion from the way this has been measuring, since that was the tight spot in the past, we're probably a little bit over our 250 that we wanted. We're probably good enough for what is normally done with field line boring as far as fitting a bushing, but not as good as what I would really have liked to see if we were doing this. This is the spot that was normally big over here. Yep, it's big again. 252. So we're going to be a little over 250 by the time we get that out of there. And it's easy enough. We don't really have anything else. Do we want to do anything else to show with our, it did the job. I mean, that's, if you were going to hire that done, that's $1,000 bill to weld that up and bore it out any day, anywhere in the U.S. Might be more than that. Now, we didn't show welding it up in the process, but of course, at the same time, if you make it instead of 251, 252, where it still works, if you ended up with this at 256 and you had to weld the whole thing up another time and start over, it's best to be careful. Best to be careful. We're playing here. Yeah, I guess that's about it. We're going to go ahead and we'll take the drill off. We will do some other stuff with the other one where we've got a little more power, and we could even do it with this one. We could do some, it cut, I mean, it worked fairly good. We could make an adapter, we can do some external turning. We could do everything with this that we can do with that, just with smaller cuts. And well, in this size range, not in the huge range, we'd need extra torque. You just need more torque, more stability. But you can do a lot with not an awful lot of stuff. You really can, once you understand what's going on. And I'm going to put that set screw down so that it'll slide back out of here. But also, one of the things I want to do here, and I haven't totally decided, plus we're getting close to the end of the year, whether we'll get this right off or not. We've been a long time waiting on me for getting, I'll take it off right there. For getting just to the point of doing this drill demonstration. It was over a year ago that I first said I would do this and show people that you could do it with a mag drill and not spending a lot of money. So some people had been waiting on that for a while. Hopefully they didn't pass away in the meantime while they were waiting on me to see that. But a lot of the time we do stuff for customers instead of so that we can show it. Okay. I'll pull the other side out here. Everything's a table. It's a saw table. So, let's grab, we got it right here. What we actually need is a 5 to 6 micrometer. Yeah, we still had that spot in there. I think this sand had been welded up before. I think these ears had been welded up before. Something that somebody else had worked on in the past. Oops, didn't quite get it. Now, there are other things you can do for size 2 that makes life easier. Like you can set a tool bit that rests against the bar or against a plug in the bar. So, and then have a screw in the tool bit. That's what they do in a lot of automotive tools. So you have a preset that you know where it's at in relation to the bar. And that way you work more with the setting of what the tool theoretically should be rather than what the measurements are. No 5 to 6. Who stole it? What were we using that for?
I don't know.
I wouldn't have expected that one to be out floating around right now. Can't think of anything. But John has backups. This one's only been out enough to check the calibration. Okay. Well, luck be with us. Luck be with us. Final measurement, we were right where we wanted to be. So thank you, Lord. Skill. 100% skill. Planning. Yeah. You just have to always be ready to skip that last cut when you're trying to get that exact skill.